Welcome to the Scientist's Villa, a place for the curious legends. Let's start today's video about, is black hole the scariest thing in the universe? Black holes may be the strangest of all the far-fetched astronomical conceptions. These black behemoths, which exist in a region of space, where matter is so densely packed that nothing, not even light itself, can escape, are also a terrible possibility. It's easy to dismiss black holes as science fiction, given how all of the conventional principles of physics break down inside them. Here's why it's so frightening. Black holes explained. According to National Geographic, black holes are dense places in space that produce profound gravity sinks. Even light cannot escape the tremendous draw of a black hole's gravity beyond a specific location. And anything that gets too close, whether it's a star, a planet, or a spacecraft, will be stretched and squished like putty in a theorized process called spaghettification. Black holes are classified as stellar, intermediate, supermassive, or tiny. The most well-known mechanism for a black hole to develop is through star death. Most stars will expand, lose mass, and eventually cool to create white dwarfs as they near the end of their lifetimes. The biggest of these blazing things, those at least 10 to 20 times the mass of our Sun, will either become superdense neutron stars or stellar mass black holes. Big explosions known as supernovae occur when massive stars reach the end of their lives. The central core is left behind after such a burst flings star stuff into space. Nuclear fusion provided a continual outward push that countered the inward pull of gravity from the star's mass while it was alive. There are no longer any forces to counteract gravity in the stellar remains of a supernova. Thus the star core begins to collapse in on itself. A black hole is created when the mass of an object collapses into an infinitely tiny point. Black holes' tremendous gravitational pull comes from packing all of that stuff bigger the mass of the galaxy's sun into such a small space. There might be tens of thousands of these stellar mass black holes in the Milky Way galaxy. Why are black holes strange? The largest black hole discovered so far has a size of 20 times that of the Solar System, Rocketstem said. The Solar System's outer planets orbit roughly every 250 years, while this considerably more massive object rotates once every 3 months. It travels at half the speed of light on its outside edge. The massive black holes, like all black holes, are hidden from view by an event horizon. A singularity, a point in space where the density is infinite, is at its core. Because the rules of physics are broken, we can't comprehend the interior of a black hole. At the singularity, time stops at the event horizon, and gravity becomes limitless. The good news about huge black holes is that people might be able to escape them. Even though their gravity is heavier, the stretching force is lower than that of a tiny black hole, and humans would not be killed. The bad news is that the event horizon represents the abyss's edge. Because nothing could escape the event horizon, people were unable to flee or report on their experiences. Black holes, according to Stephen Hawking, are steadily disappearing. Black holes will be the final remaining things in the cosmos long after all stars have died, and galaxies have been ripped from view by the relentless cosmic expansion. Nature has figured out how to create black holes of all sizes, from star carcasses a few times the mass of the Sun to monstrosities, tens of billions of times more massive. That's the equivalent of comparing an apple to the Great Pyramid of Giza. Astronomers unveiled the first ever image of a black hole at its event horizon, a 7 billion solar mass monster in the heart of the M87 elliptical galaxy, only last year. It's about 1,000 times bigger than our galaxy's black hole, whose discoverers won the Nobel Prize this year. Most of the time, these black holes are dark, but when their gravity draws in surrounding stars and gas, they flare up and emit a massive quantity of radiation. Massive black holes pose a threat on 2 levels. If a person or an object comes too close, the massive gravity will suck it. The high-energy radiation will bombard the object once it activates its quasar phase. Black holes' death. When a big star dies, black holes are predicted to arise. Gizmodo said the star's core collapses to the densest state of matter possible, 100 times denser than an atomic nucleus, when the star's nuclear fuel runs out. Protons, neutrons, and electrons are no longer separate particles in this density. Black holes are discovered when they circle a regular star because they are dark. Astronomers can deduce the features of the regular star from those of its dark partner, a black hole. Nothing, not even light, can escape black holes, which are matter graves. Anyone who falls into a black hole would suffer from spaghettification, a painful process popularized by Stephen Hawking in his book A Brief History of Time. The black hole's immense gravity would tear you apart in spaghettification, separating your bones, muscles, sinews, and even molecules. In his poem Divine Comedy, The author Dante described the inscription, "Over the gates of hell to abandon hope once a person enters the place." Subscribe for more, and press the bell icon for never miss any updates. See you in the next video.